Okay guys, I'm gonna get you guys to settle as soon as you can. Find your seats. I'm gonna get started here. Okay guys, so one of your big tasks over the next couple of weeks for this course, actually fairly soon, will be to form your teams. And I know that you guys have had an opportunity to work in engineering teams before. And one of the biggest complaints that we have about APS 111, 112 is that you don't get to pick your own teams, okay? And students like to have that agency and be able to kind of select who they work with. And we're going to talk about some of the things you should think about as you're doing that over the next little while, okay? So we should all know the constraints already. We're talking about teams of 3. Some people already asked about whether you can work in teams of 2 or 4. Ideally, we're shooting for teams of 3. That's the ideal number. In some rare cases, you wind up working in teams of 2. In even rarer cases, teams of 4. But obviously, we're trying to shoot towards teams of 3. Okay, so find yourself 3. If you are a group of 2, by the end of the second week, when we're starting to form those teams, we will still try to find somebody for you to put to make you a full team of 3. Okay, we know the conditions already. There's been a lot of questions asked on Piazza about kind of variations from this, and so you can go there and see what the responses are. But basically, you're in the same tutorial and practical slot. Okay, now how many of you are actually already in teams? Okay, that's great. That's a lot of you who are in teams already, but also a lot of people who have the opportunity to think about who they want as a teammate, okay? So let's think about this. This is your first chance really to get to choose an engineering team and your team members. What principles or what criteria are you going to use for choosing team members or forming a team? So any ideas that people want to shout out from the audience? Just raise your hands, or C3, okay? I'm gonna let that one go. Okay, C3?
Was it us?
By accident, or you good? Yep.
Familiarity, maybe?
Okay, so familiar with someone you're friends with, somebody you've worked with before in the past. Okay, that's a good idea. Other thoughts? Other criteria or principles for picking a team member? Okay, A09.
Like good communication and that you guys are comfortable talking together.
Good communication, you guys are comfortable talking with each other, you have a good rapport, okay? That's a really good idea as well. Now, sometimes it takes some time to develop that good rapport as a team, but if you have it to start, that's already a really good thing, okay? Let's go with F06. Okay, so everybody in the team should have a common goal. So there should be some sort of commonality towards it, some sort of maybe common approach. Yeah, that's a really good idea as well. Okay, D10.
Complementary skill set.
A complementary skill set. So you're thinking somebody who is maybe a really good communicator, somebody who's really good at coding. Yeah, it's a really good thing to think about as well, okay? I'll go with F12 and then we'll just move on a little bit. F12?
Similar work ethics?
Similar work ethic, right? So some shared values and some shared ideas about what you want to get out of this course. Okay, so all of those are much more responsible than the ideas that I'd thought of initially, right? Maybe you just want to find an awesome coder. Maybe you want to find somebody with the same sort of interests. Maybe you want to find somebody who you know is a high performer so that you do well in that team as well. There's lots of reasons and ideas for choosing your teammates. I want you to think about 3 things in particular. Now, some of them have already been mentioned, okay? But I want to kind of emphasize the importance of all three sorts of these things. So shared values and complementarity, we've talked about kind of briefly. It's remarkable how important simple logistics are, right? Are you both commuters? Where are you going to work? When do you like to work? Are you somebody who works during the day and needs a full 8 hours sleep? Or are you somebody who works through the night? Okay? How and how often will you communicate through the course of this project? The number of miscommunication snafus I experienced last year because people were using slightly different platforms and they weren't checking those platforms all the time. So make sure that you kind of have similarities in that case, okay? And then also, are you somebody who's typically on time, or are you somebody who's often late? That might have some impact on how well your team works together, okay? But the logistics are really important. What tools you like to use as well. All of these things are things that are important considerations. There are some things that you can't change, like whether you're a commuter or not. Certainly, if you migrate to certain tools, you can make that discussion, that logistical decision later on. But there are some things that are pretty important that you should have in place at the start, okay? Shared values. So we talked about that before. Expectations for group members and yourself, not just for like levels of achievement, but also for behavior, commitment to the team and commitment to the project. And what is it that's really important to you when you're dealing with others, right? Are you just looking for a base level of competence, or would you like someone who's nice? Somebody who speaks in a nice manner? Is that important to you? Because it says a lot about how you will connect with one another as teammates. And it speaks to kind of this importance of developing a mutual respect and trust and accountability within your team. Okay? And then the last thing we talked about is just that idea of complementarity. And this is not just about whether you're a good coder versus a good communicator, right? The two halves of the course. But also whether you're good at debugging versus doing the actual initial coding versus the design thinking that's required to go into the project. It's also about whether you're a creative thinker, whether you're good at creating creative solutions to problems, or whether you're a really methodical thinker, right? And then the idea of whether you're a conceptual level guy or person, or whether you're a really detailed, focused thinker, right? You want to have representation of all of these kind of skill sets and focuses in your group, okay? Now these two ways of of kind of looking at the two sets of principles or ideas for forming a team, they're not mutually exclusive. These ideas about, you want someone who's fun with a similar personality, who's got a 90% average or something, those aren't necessarily bad criteria. And there are good reasons to use both those sets of ideas for forming your team initially. But what's important is that you have that initial discussion up front as you're forming the team. The one thing I do want to point out is that there is, like there is a ton of research into technical communication and engineering communication, there's a ton of research here too. Right? So there's journals in management and group dynamics and team performance management. Google has spent a lot of money exploring and looking at the idea of what are the fundamental building blocks of an effective team. And they did that in industry, and they had a whole research project involved in that. What they found is really interesting. Right? What they found really confirmed a lot of the ideas that had been in place. And it's really that a team that listens to one another, okay, and kind of builds a relationship with one another are the most successful ones, okay? So there's a lot of research here too to look at, and that research really kind of helps you build a set of practices and principles and tools to help make for a productive and happy team. Now, one of the things that the communication instructors are going to do as your project managers in those meetings is kind of talk about your strategies for doing that, and kind of help bring some of these tools and strategies to your team function, okay? There's also a really effective guide to hybrid teaming that applies to in-person teaming as well that you can get from iLead, which is an organization in engineering, okay? So as you kind of think about and put together your teams, remember there are some tools that will help you get additional team members if you're looking for team members. And if you have any questions or if you have any concerns, feel free to email me. Ultimately, you will get into a team, so don't worry about that too much. Try to place yourself in a team through Piazza or other tools so that you can choose your own team and have some agency in who you work with over the course of the term, okay? All right, leave it to Professor Betts.
Can everybody hear me? Okay, that was a more graceful switch over for my microphone than Tuesday, so I'm already doing better. So I'm going to talk about, I guess, a technical part of working in a team, which is version control. So this is an important technology for developing software and actually hardware. Hardware uses version control as well, and for collaborating within your team. And the particular version control system that we're going to use is Git, which is nowadays probably the most popular one, but many of the principles of what we're talking about apply to all version control systems. How's the volume in the back? Is it too loud, too quiet? What do you think? It's good? Okay, sounds very booming to me, but that's fine. Okay, so let's start with why we need version control. I don't want to start with like a bunch of commands that you go, why am I using all these commands? So let's start with the problem we're trying to solve. So I've got a project, got a couple of C++ files, couple of header files. I'm working away on it. I'm not really Tony Stark, but let's just say Tony Stark is doing it. So your typical cycle is you edit, make some changes, you build it, you test it, and you keep doing that over and over and over again. And things break all the time. So I've been building this program for a while, used to work, suddenly it stops working. I made some change and something's not working now. Now, if I just made one change, right, and I tested right away and I found that it's not working, well then it's probably not very hard for me to remember what I did and undo it. But unfortunately people don't always do that, so maybe I've made a bunch of changes and now I realize some test is failing. Now this is going to be painful. I'm not quite sure what the last thing I did is. Maybe I have to try to remember everything I did over the last 4 or 5 days and undo them all. So we need a way to go back to a previous version of a program, because I'd like to just go back to the previous version, see if this worked there, and now I know what mistake I made. Okay, so I want you to discuss at your table for a very brief period of time. We'll stick up a timer, give you like no more than 1 minute. I'll try to do even less than that. And let's see if I can send that to the, successfully send this to the screen. Okay, that looks good. What would you do? Okay, don't say use Git. Okay, that's a good answer, but that's not the answer I want. If you'd never heard of Git, you never heard of source code control, how would you handle this problem? You want to be able to go back to a previous version. Time's up. If you got an idea, I see some people have already buzzed in. Well, you know what? F12. Did you intentionally buzz in? I'm going to turn on your microphone here. I think. So I think you're, oh wait a second, actually I've got 3 people with their microphones on right now. Okay, I'm clearing it, C03, I think you're trying to buzz in, so we're gonna try taking you. Okay, what would you do? C03, did you intentionally buzz in? All right, you passed the first test, awesome. Now, do you have an idea of what you would do?
Make multiple copies.
Okay, so make copies, right? So you're gonna make copies, maybe zip it up or something. And yeah, that's a reasonable solution. Actually, it's what I used to do before I used revision control. And if you didn't know how to use a revision control system, this is what you should do. Now, I'm gonna ask you a follow-up. Do you have think of any downsides to that?
You're taking up your precious SSD storage.
Okay, so you could get a lot of backups, right? If you do this, you should do it often, because if you just do it once a week, that's still a long time to kind of go back if you make a mistake. And if you do it really often, like you're doing this every half hour, you could get a lot of backups. So better than nothing, but not ideal, okay? Yeah, so one problem is got to copy them often for this to work well. And that can take a lot of storage. Another problem is, okay, now I've been copying my files every 5 minutes or every half an hour, and I figure out that I've got a problem. I don't have a very organized procedure to go back through old versions. I've just got all these old backups, and I got to start unarchiving them and going and just looking at all sorts of them. So again, better than nothing, but not ideal. And also, you might forget to do this. So unless you set up some timed job that does this automatically for you all the time, you're often going to forget to do it, and that's when you make a mistake and you really wish you had a backup. Okay, so we have a problem. We'd like to be able to go back to old versions in a more organized way than we're just copying it all the time. Okay, here's my second problem. Okay, so most software projects, well, pretty much all meaningful software projects and hardware projects are done in teams, not done by yourself. Okay, so I'm editing a file, and while I'm doing that, it's a bigger problem. We bring in Batman, right? So the comic movies are not doing too well for Marvel or DC this year, so we decide let's fuse them together. Maybe together they can write some software to make a good movie. So and now Tony Stark and Bruce Wayne both edit the same file at the same time. So Tony saves his changes, but then Batman saves his changes and overwrites Tony's. Okay? They both build, and Batman's happy, but Tony Stark is not happy. His stuff's gone, right? Batman overwrote his changes. So we've got some chaos. Once we start having a team, people can be editing the same file, overwriting each other's changes. This isn't going to scale well. Okay, so we need a way to prevent conflicting edits to a file. Okay, so I'm going to give you another minute. Discuss on your team, well, how would you fix this? Again, it can't be use Git. That is going to be the answer. But if you've never heard of Git or revision control, what would you do? Okay, so time is up. You've just heard C03 knock it out of the park on the previous question. So some other team maybe wants to challenge by saying, hey, we got a great solution for this. So who wants to buzz in on this? Okay, F13. First ones, where are you, by the way? There you are. Okay, so speak loudly into the microphone. What would you do to solve this?
Each person makes a copy of the file and edits the file, and then you merge the files together.
Okay, so everybody's got their own copy of the files, edit them, and then merge them together. And that's a good solution. That's actually moving towards revision control. Everybody's got their own set of files, does whatever they want, and then they put them back in some central spot. So you're essentially doing kind of manual revision control. Now, any problems you can see with this? I think you have to speak louder. Oh, no, you went away. Sorry about that. Okay, so I don't know why you went away. Okay, let me try this again. Okay, your microphone's back on.
For example, if one person edits the same function as the other person is editing, then you might face a problem where you'll have 2 edits for the same function.
Yeah, so it's better. Everybody's got their own copies of the files, and when they've done some tests and stuff, they'll put them back together. But that putting back together could still be a bit chaotic, right? So whenever you go back to the main master copy, how do you do that? Do you send everybody an email saying, send me all your changes and I'll make sure I put them all together? It could be still kind of chaotic. But that is still a reasonable thing to do. Any other ideas? I see A09. Let me take A09 and see if you have any different ideas. You got to speak really loud.
Yeah. Wait, is this loud enough?
I can hear you, but I'm not sure about them.
So yeah, maybe have one master file, right? But communicate with your teammates to set boundaries in terms of what each member is responsible to work, which function each one is responsible to complete, and that that person is only responsible for those specific functions.
Okay. So that makes sense. Also a very reasonable idea. Okay, so your idea is have one master copy. Everybody doesn't have their own copy, but everybody agrees which parts they'll edit. So before they make any edits, they talk to other people saying, hey, I'm going to change this part, nobody else change this part. That also can work. Sometimes you might miss the email, etc. Well, I think I have a few flaws in that. So these are both reasonable solutions, and if you'd never heard of source code control, you should do these things. Essentially, let's take the second solution first. There's one copy, and basically everybody negotiates who's going to edit what. So try to split up who's doing what and when. So you can email people when you start editing a file, but there's some problems with that. Basically, maybe the person didn't read the email, 2 people sent the email at the same time, so you wind up, even though you were trying to organize access, that 2 people did change the same file. And you could make this work with 2 people not too badly, but if you have a bigger problem, you have to bring in lots more team members, it doesn't scale very well. Everybody's kind of splitting up the files and emailing each other when they're making changes isn't going to work super well. Sometimes people suggest a Google Doc. Google Doc, at least you don't lose each other's edits so much. You've got one master copy and you can all see each other editing. But it still can get slow if you have lots of people editing it, and you still could wind up both editing the same part around the same time and losing some edits. It's probably better than just not using Google Docs, but still doesn't work perfectly. Okay, so the third problem, it's maybe the biggest of all, is let's say Tony Stark makes a change to this file. At the same time, Bruce Wayne makes a change to a different file. So there's no problem with them overwriting each other's edits, right? They've decided we're going to edit different files. They each make their changes and save them. They compile the program. They build it, run the tests. Okay, and it turns out that Tony's tests fail, and they fail not because of bugs in his code, but because Bruce Wayne's in the middle of writing some stuff. So he's changing some stuff, it's only half done, it's not really ready to be released, but it's already in this master copy. So it's impeding Tony's ability to work. So our third problem is we need to have a way to control when our changes become visible to others. We want to work, be able to break things, have half-done things, etc., but other people don't want to see that. So this doesn't quite work either with one copy. And I don't know of a simple solution to this, right? All solutions that I know of to this, essentially the solution that was proposed earlier of everybody have their own copy, and then they'll put things back to a master copy only when they're ready, that essentially would be a workaround for this. That workaround, though, is starting to move towards revision control. So we're going to talk now about how revision control solves all these things. Okay. So we need revision control to solve those 3 problems, with the third one maybe being the most fundamental of all. The most popular revision control system these days is Git, so that's the one we're going to talk about. Does anybody know who wrote Git, by the way? Who's the original author of Git? So I'm going to clear everybody. Let's see. If you know the answer, put your hand up or buzz in. Seriously, nobody knows this? Okay, if you know the answer, I will give you a chocolate bar after class. Okay, so now let's see. Okay, so I didn't used to like to resort to bribery, but then I had 3 children, and at a certain point, you become comfortable with bribery, right? It's just okay. So I'm going to give you a second. Put up your hand if you know. Wait a sec. Did you look it up on the internet? Ah, no, I'm not going to you. You're looking too much up on the internet. So anybody know? Okay, so I'm going to F. What are you? Okay, I see you there. Okay. First question. Did you look it up on the internet?
No.
Yes. Okay. I'm going to let you answer. Who wrote Git?
Linus Torvalds.
Linus Torvalds. Right. So for the bonus, in which if you get the bonus right, you get to give a chocolate bar after class to anybody you choose, right? Or maybe secretly you eat them both. I won't know. But I recommend you give it to somebody else. Did Linus Torvalds write anything else?
Linux?
Yes, he also wrote Linux. So it's a pretty successful career, actually, if you think about it. So it's a pretty impressive achievement. Okay, well done. Afterwards, come up, grab a couple chocolate bars. Yes. Okay, so what's the key idea of, this is the key idea of all revision control systems, including Git. So you have local copies, much like it was suggested by one of the teams, and you have a global repository. So Tony Stark has his own working copy, right? His own files on his computer that he's working with, he's editing, he's compiling. Bruce Wayne has a completely separate working copy. He's compiling, editing, etc. When they are ready to send changes to the central kind of repository that stores the really important software, they use commands from Git to do so. When they want to get changes from their teammates, they use commands from Git to get those changes, okay? So we have this central repository that's the long-term storage, and we have these working copies, which is what we're working with day to day. Okay, so let's look at how this solves our problem. So we're going to start with problem 3. How does this solve that I need to be able to control when my changes become visible to others? Okay, so Tony Stark's making a change. He changes the red file. Bruce Wayne's making a change, changes the green file. Okay, so each of them should test their program. So you never put back code into the central repository that is untested, right? That's not a good idea. So each of them tests. Each of them figures out, oh, it works. So now they're going to put it back into the central repository, and that's done with a couple of Git commands. And I'm going to gradually go through sort of more detail of how Git works. But at a high level, we use these 2 commands, commit and push, and together those 2 commands will get our changes into this Git repository. Okay, so Tony does that, and that file turns red because his changes are there. Bruce Wayne does that, and that middle file turns green because his changes are in there. Okay, so now each of them has completed some functions. They'd like to see, well, maybe my teammate did something. I should get those changes. So they can now update their local working copy with changes that have been made by others. And to do that, they use another Git command called pull. So pull takes whatever is new in that central repository and brings it into their working copy. Pull has an optional argument -r. We recommend that you usually do use that optional argument. I'm going to show you why later in the lecture. It basically makes it a little easier to follow the changes, or what are called revisions, to the software. So this -r is not necessary, it's optional, but it tends to produce a cleaner, easier to understand sequences of changes to the software. Bruce Wayne does the same thing. So he executes git pull -r, and it pulls in Tony's change, pulls in that red file. Okay, so now they're both up to date. What do you think they should do right now? Okay, so I just did a poll, I pulled in some changes for my teammates. What's the next thing I should do? Should I start coding? So who thinks I should start coding? Who thinks I should do something else? Okay, what else should I do if I don't code? So I'm going to go to D12. Looks like you have an idea. Actually, D10. Looks like you buzzed in. So D10, what should I do?
We did it. It's just been on for a long time.
Oh, it's okay. I should turn off your mic. Okay, C12. What should I do? Where are you, C12? There you are. What should I do? Or has it also been on for a long time? Okay, I'm clearing you too. Okay, so I probably shouldn't start coding. There's something else I should do before I code. What should I do? What do you think? There's only so many things I could do. I mean, I could take a coffee break, I could go play lacrosse, but I'm probably not looking for an answer that random. So what should I do before I start coding, after I pull in changes from my teammates? Okay, so A09, I'm going to turn you on. What do you think?
Revise the changes.
You should what?
Revise the changes.
Well, what do you mean by revise the changes? What does that mean? So my teammates made, I have my code, now I pulled in changes that my teammates made to the code. Okay, so let me ask this another way. It's a leading question. Actually, well, I got one more person, B06. You're my hope. What do you think I should do?
So whenever we are taking the modified version, whatever it is saved in the GitHub repository, we need to test the code of our whoever is something new.
Right, so you say test. And that's exactly right. I should not trust my teammates, right? Not because they're bad people, but because it's very easy to break things. And they might not, their code might be perfectly fine, but combined with my code, I also have changes, maybe it's not fine. I want to know that right now, before I change one more line of code. Because if something's broken, I want to know it right now, because it's going to be easier to backtrack, because there's fewer things that could be wrong. Okay, so when I pull in new code from my teammates, I immediately build, and test, okay? So I'm making sure that any changes they put in plus my changes work, and Batman should do the same thing. And since my teammates are supposed to be changing their stuff and hopefully working on different parts of the program, it should all just work, but sometimes it doesn't, right? They made a change that seemed fine, I made a change that seemed fine, together they don't. I want to know that right now. So these are called integration errors. They happen all the time. You want to fix them right away. So when people start, actually not just writing software, but just designing, they think most of the work is design. It's actually not. Most of the work is debugging. Things are broken, you fix them. So you want your flow to be very efficient for debugging, which means you have small changes that are being verified, not I just kept going hoping it would all work out. 3 days later I tested, nothing works, and I don't know what to do. So test it right away, fix problems right away. Okay, so the corollary of that is as you're working, you want to you write a little bit of code, it achieves a little bit of new functionality, you test it, you make it work, that's when you commit, that's when you push. Because you want to send back small updates, not just gather them together for many days and then just put it all back at once. Because if you and all your teammates do that, you're much more likely to have integration errors, where all those changes together don't work. And now you've got a big mess, and it's late in the project, and there are recriminations. Don't do it that way. The reason I'm emphasizing that is human nature seems to be, I'll just keep going, I don't want to stop, I don't want to commit, I'm just hoping for the best. Usually that doesn't work out. Do lots of small commits. Okay, so that was problem 3. What about problem 1? So problem 1 was we need to be able to go back to an earlier version of the program because mistakes happen all the time. So you will have to go back and look at an old version. Okay, so the Git repo that I showed you is a little more complicated than what I showed you at first. Before I just showed you, you had working copies, and then you have this repo that also is a copy. The repo actually has revisions in it. Okay, so the actual revisions are tagged by long hash strings, which means like a long sequence of like hexadecimal characters. But I'm just going to give them nice short names. So R1 for revision 1. So when Tony Stark commits and pushes his changes, so that red file, it doesn't actually change the file in revision 1. It makes a new copy. So it automatically makes a new revision called R2. And in that R2, we have these red changes. When Bruce Wayne goes to make a change, commits and pushes his change, it makes another revision, R3. Okay, so every change that we commit and push makes a new revision, which means we can go back to any one of these old revisions if we want. Okay, when I do a git pull, I bring in the changes from the latest revision. Okay, so Tony does that, he gets this green update. Bruce does that, he gets this red update. Okay, so it works the way I showed you before, except we're getting all these revisions, so we have a time sequence of all the changes. Okay, so git pull-r is what updates your files to match what's in the repo, your working copy. Okay, so let's say I do a git pull-r. I bring in the latest changes from Bruce Wayne, so those green changes. I build, I test, and it fails. So something went wrong. Okay, so Tony suspects that the problem is files that Bruce put back, right? If he's been really rigorous, Tony's been testing his software, it works. He does a pull, he tests right afterwards, it doesn't work. So he has strong evidence that there's actually a problem from some code that his one teammate has put back. But he needs to produce very clear evidence of where the bug is so that he can get Batman to fix it. Okay, so what he can do is he can basically check out an older version of the software. So checkout is the command to basically take a different version of the software from the repository and bring it into your working copy. Okay? And Git has a term called head. Head is basically a pointer. So normally head points to like the last revision in development, okay? Because that's where I want to work, that's where my commits should go. But with checkout, I can say I want to do all commands for Git start with Git. So you say Git, and that means this is a command for Git, and then there's always what is the actual command. So I'm saying Git checkout, and then it takes an argument, which is which revision. So I'm saying I want revision 2. So I'm intentionally going back to an old version of the program. Okay, so revision 2, let me show that animation again. So when I do this checkout of revision 2, I'm going to go back to this software, which doesn't have the green code. And I'm also going to update, this happens automatically, this head pointer. The head pointer it's Git's pointer of where are your changes going to go? What revision are you working with? Okay, so both those things happen. I can now build this older revision, test it, and it passes. Okay, so now I've basically proven that some change in revision 3 is a problem, right? Because revision 3 doesn't work, but revision 2 does work, so it's clear where the problem is. So now I can go and examine what happened. Now I can't actually if you actually do this, Git won't let you make commits to this revision. Okay, it'll give you a sort of confusing message called can't commit in detached head state. Basically, Git understands this isn't the last revision. It goes, there's another revision after this. If I let you make changes to this, it's going to be kind of chaos. So you can look at this, but it's not going to let you change it. So what I can do is I want to check out the master now. So I've proven that R2 works, R3 doesn't, but I'm now going to go back to the master branch. Okay, so I do, master is basically another pointer that means the last commit in this sequence of commits, okay? So I say git checkout master. That gets me back, gets my code back to the latest. I'll show you that animation again. So the green code comes in, because I have revision 3, and this head pointer, where my commits go, is back on the last revision. Okay, so this code is broken. My working copy has now got the broken code in it again. But I had to do this checkout to kind of get back to the tip of development so I can actually make changes. Because Git won't let me just change some random revision in the middle of the history because it doesn't know what to do with that. It's like there are all sorts of changes after this. You're kind of throwing those away. You shouldn't do this. So now that I'm pointing at this master, this tip of development, I can undo the changes that were in revision 3. Okay, so Bruce made some changes here. There's actually a convenient command to undo them. And that command is revert. So I can type git revert R3, and basically Git will go look at what are all the changes between R2 and R3, and it will undo them. And that after you've done that, you say push to put it back in the central repository. And we now have an R4. The R4 has those changes undone, and it's at the tip of development. It's the last revision, so we can keep making changes to it. So this is the sequence I needed to do to get rid of that bad commit. Hopefully that all makes sense. Some of these commands you're going to have to work with a bit to kind of gain familiarity with them. So that's why in milestone 0 we have you playing with Git. So yeah, ece297. Let me turn on your microphone if I can. Yes?
So git revert removes, what does git revert do?
Git revert, okay, so Git doesn't ever delete a revision. What it does is it basically finds all the changes that were made in revision 3, and it does the opposite. Okay? It basically undoes them all.
So it kind of makes the master, so it makes the master the previous?
It basically makes a new revision R4, but the actual code in R4 would be identical to what's in R2. Okay? But we can go back to R2 to look at it, but we can't change R2. It's just done, okay? If we want to get rid of those changes, we have to use this command to say do the opposite.
And between git push and git commit, do they both do the same thing, or do you need to do both at the same time?
I'm going to get to those in a minute. So right now I'm just showing you commit and push one after the other, because there's another level of complexity that I'm about to show you. Okay, so good question, but you'll see that hopefully in the next few minutes. F09, did you push your button on purpose or not? You did? Yes? Okay, so let me go to you. Yeah?
What if you wanted to go back to R1 instead of R2?
What if you wanted to go back to R1? So you could do a git revert R3, git revert R2, right? So you could do multiple reversions. You also can, you can just start changing the code. So if you just find there's like just a certain bug, you can just change those lines and commit that too. So revert's not the only thing you can do. It's just convenient if a recent commit turns out to be wrong and you just want to undo it. You could use revert on multiple commits if there are several you want to get rid of. And if there's just some broken subroutine, you could just go in and fix it or delete it or whatever you want, because you can manually edit the code too. Does that make sense? After you've done that, you want to commit and push. Okay. And C05, do you also have a question, or is it accidental?
Check out master before I do revert.
Sorry, could you say it again, louder?
Do I always need to check out master before I revert?
I couldn't hear you, sorry.
Do I always need to check out master branch before I revert?
You only need to do that, so we had to check out the master branch because of the fact that I used a checkout of an old commit in order to look at it. So the checkout of the master branch is to get me back to the tip of development. If you had never checked out that old one, then no, you don't have to do git checkout master. Does that make sense? So git checkout master is actually moving the head pointer to there, okay, and updating my code. If I had never gone back to an old revision, I don't have to do that. Like if I just knew this commit was bad, I look at it, I go, it's bad. I don't need to prove it. My teammates believe me, then I could just do git revert. But in the sequence I showed you, I actually did a checkout of the old code to sort of investigate further and prove it. And the git checkout master was to get me back on the tip of development so I could start working again. Does that make sense? So B06. Yeah?
I was kind of confused in terms of the...
Say it really loud into the microphone. These microphones, unfortunately, are not that powerful.
So I was kind of confused about the chain of command that you have for git checkout master, git revert R3. So do we get to know which version the master itself is?
The master, yeah, master is a pointer. So master means like, in the context of, there are lots of ways to use Git, but the way we set up your projects, master is like the tip of development, okay? It's like the last commit, and it's a pointer, it's like a nickname. Does that make sense? And we want the head, which is like where are my commits going to go. In order to make any changes, you need your head to be at that tip of development. So the git checkout master was to get me back there.
Can we do git revert master?
You can do a git revert command without doing a git checkout master. Git checkout master was just to get me back kind of where I need to be to do development. Does that make sense?
We do that, we will do the same thing, right?
Yeah, yeah. And as I said, I'm giving you a quick overview, but it is going to take time to get comfortable with these commands. So don't worry if you go, wait, I saw the lecture and I still don't know exactly which command to type when. It's going to take a little bit of practice. Okay. Okay, so Another way that Git helps you with this problem of going back to old copies and figuring out if there's a problem is the git log command. So the git log command shows basically a list of all of the files modified by every commit and a message that you put in with every commit. So if I type git log, it's going to tell me there are 3 revisions. In revision 3, we changed this green file, and Batman said, I'm putting in some really risky code. Revision 2, Tony Stark changed this red file and he put a comment in saying, I've tested this super well, and revision 1 was the original one. So git log tells me the whole history. So this is part of solving our problem. If we've made lots of backups, how do we figure out which one to go back to? The backups inside Git are better because they have messages and they know what changes were made. So you can examine that with git log. You can also check, let's say I'm suspicious of revision 3. You can check, well, what exactly did I change? And there are a couple different ways to do that. You can use the git diff command. So I could say git diff revision 2 versus revision 3. That'll show me all the changes. I can also use this command, git show. Git show will tell me these are the things that were changed in detail, like every line of code that was changed in revision 3. So those 2 commands help me look at old revisions without checking them out and just see what changed. Okay, so the git diff output, this upper command, you can use this to compare any 2 revisions. They don't even have to be one after the other. This is what it looks like. So it basically says the changes are in file 2. Okay, and if you go back here and look at it, I guess I didn't number these very well, but these changes are in file 2. It tells me I'm on line 192, and I'm in this function called superhero setup. It shows me a little bit of code that's the same in both, and then it shows me a line that has a plus. Okay, so this plus line means it's in the new revision, R3, but it wasn't in the old one, R2. And this minus line means that this was in the old revision, R2, but it's not in R3. Okay, so what's happened is, basically Bruce Wayne changed this line that said Iron Man was the best to this line, which says Batman is the best. So I can tell what was changed, what lines were deleted, what lines were added, and that can help me track down bugs. Okay, do you think one of the other problems we said about backing things up all the time is it's going to take lots of storage. And now I'm telling you every single commit, and you should commit often, is going to make a new revision. Is this going to take lots of storage? What do you think? So jump in if you got a question. Let's see, F13's in here. I'm hoping it's for this question. F13, do you think it's going to take lots of storage? What do you think?
Maybe.
Maybe? Okay. That will always be true. So this is a 50-50. Do you think it's going to take who thinks this will take a lot of storage? Nobody? Who thinks it won't take much storage? Okay, so D06, I'm going to you. You're actually right, it doesn't take that much storage. Why not? Yeah, I think it's working. I can hear you.
Okay, I think it's because the files are probably pretty small.
Yeah, it only stores the changes. So it's smarter than just storing all the software. So it does a better backup than you would do by hand, where you copy all the files. I mean, Git is set up of it knows you're going to make many changes over time, and in fact, you would like to be able to say what changes were made. So it stores the changes. Even for a really big software system, a typical commit doesn't change very much. It's actually bad practice. You should try to keep your commits small. So if you commit often, it's still okay. It'll cost some space, but it's not that bad. Okay. And I'm going to take the last minute. So our third problem was, how do we stop conflicting edits to a file by different people? There are 2 basic approaches to this. One is lock-based, which is essentially one of the student answers of how we prevent this was, kind of email people. Tell people, I'm about to edit this file. That's essentially how lock-based systems work. Before you edit a file, you have to type a command that gets you a lock, and now nobody else can edit it. This is used by some older revision control systems. you should not use those systems, okay? I used one of those systems early in my career. It was horrific. I remember the salesperson for it phoned me up one time for feedback, and I said, this is God's worst creation. He didn't quite know what to do with that feedback, right? It wasn't super constructive, but they're not good systems. The other way that you can do this is what are called merge-based systems. Merge-based systems essentially